Good afternoon. Welcome, everyone. I'm John Keenlyside. I'm a Director of Cloud Platform Engineering at RBC. I've been at RBC for over 2 years now. Before joining RBC, I was working at IBM for many years, working on compilers, databases, and VM orchestration software. Outside of work, I enjoy some cycling and swimming. Ron, I just noticed there seems to be a spelling mistake on the first slide.
Oh no, John. Are you serious? Hi everyone. I'm Ron Coffey. As our title says, this is an approach to site reliability engineering. I'm a cloud engineer at RBC. I've been a long-time employee with them, holding many different roles within operations and support. I've worked within our virtualized infrastructure and was one of the founding members of the Greenfield deployment. Outside of work, I enjoy participating in many sports, and I am currently a volunteer coach with a non-profit sports club. So first things first, some housekeeping. It's the safe harbor statement. Everything that we use is within GA, so we're clear from this. I'll give you a couple minutes to read that. There you go. So RBC, that's our global brand for Royal Bank of Canada. It's one of Canada's biggest banks, among the largest in the world on market capitalization. RBC has over 86,000 employees serving 16 million clients, and we're one of North America's leading diversified financial services company.
So Ron and I are part of the cloud program at RBC. The cloud program's mission is really to provide next generation platforms and services via a multi-cloud strategy. One of those platforms is the Pivotal platform running on-premise on VMware infrastructure. We are enabling the bank to transform legacy applications into cloud native and adopt agile principles.
So here's a quick agenda that we'll go through for today. But our talk is basically about portraying our adoption of site reliability engineering, the guiding principles that we use to operate the bank's cloud platform. The system supports critical banking functions and other critical workloads, serving millions of requests per day to our external clients. During this journey, we set our minds to applying software engineering principles to solve operational challenges associated with our on-premise cloud platform. We're going to share our experience with adopting an SRE culture and how we overcame its challenges. And within the platform team, SRE, or Site Reliability Engineering, drives decision-making around our backlog, enables the team to take risks, and ultimately allows our team to make informed decisions around running Pivotal platform as a product. So a quick introduction to the cloud platform team. We're a small team, a 2-pizza box team of engineers. We support 3 different platforms in total. One is the Pivotal platform, the other is the Elastic Cloud Enterprise, as well as Confluent Kafka. For the purposes of today's presentation, we are going to focus on Pivotal platform. We actually have 4 Pivotal platforms deployed, hosting over 7,200 application instances, which support over 200 application teams. This is roughly about 10% of the bank's total number of apps, so we do expect to see adoption scale quite a lot. Of these apps, however, the most critical being our critical banking functions. So obviously we needed to adopt an SRE mindset here. Just to go over a quick review of SRE and how we interpret it. So SRE, or Site Reliability Engineering, is defined by Google as a practice that includes aspects of software engineering to solve IT operations problems. Its goals is to measure and maintain user happiness through ensuring platform availability and the release of new features and enhancements. As such, it must be considered a feature of the product. SRE, as mentioned, is a set of principles defined by Google in their SRE book, and SRE is not a technology. An SRE fundamentally believes that systems operations is a software problem. We want a computer to do as much work for us as possible. SRE measures failure and availability in a prescriptive manner using SLIs, service level indicators, or SLOs, service level objectives. We want to define and deliver a given level of service to our users. And to do this, we use intuition, experience, and understanding of what the users want to define these service level indicators, as well as service level objectives. SRE allows engineers to balance the risk of unavailability with the goals of rapid innovation and efficient service operations, so that users' overall happiness with features, services, and performance is optimized. Continuing on with a review of SRE, you could say reliability, one of the definitions would be to be able to produce results time after time, or how much a person or platform can be depended on. Some quick definitions we have here are service level indicators, or what we refer to as SLIs. An SLI is an indicator of a level of service. It's a measurement of the user's expectations. SLIs are coded with something that is programmatically measured as a ratio of two numbers. So take good events divided by total events, and that's your number. So the SLI ranges from 0 to 100%, 0 meaning nothing is working, and 100 meaning nothing is broken. A quick example of this is the end users of a pivotal platform expect to CF push an application and the application to be available and return an HTTP code of 200 within, say, 2 minutes. If that CF push fails to respond, or responds more slowly than our broadcasted service level objective, then the end users will be unhappy with the service. Service level objectives, or SLOs. It's a threshold established for the defined service level indicator. An example is the percentage of the SLI testing that must pass for the end users to be generally satisfied with the service. Next is key performance indicators, or KPIs. Those are given metrics in the form of a counter or a gauge value. This metric helps show the health and status, the performance or usage of a given component or a set of related components. So think of something like capacity management, where you're relying on having enough memory to be able to accommodate users' orgs and spaces for them to push apps to. And the next topic, or key term, is error budget. Error budget is directly related to target SLO percentage. The error budget represents the quantified amount of downtime or lowered performance levels that is allowed within a 30-day period. Each time the SLI check fails, or it negatively impacts the SLO, which in turn consumes error budget. For example, our SLO for a single platform is 3 nines, which translates into roughly 43 minutes. And this is within a 30-day rolling window. You can see here from this chart what it would actually take to meet 5 nines. A lot of people will suggest that they can target or achieve 5 nines. That's how much downtime you would have in 30 days. So really no time for error. There's no manual intervention there. That's all automated failover and failbacks. Okay, so SRE at RBC, or at RBC Cloud. So what did we do to bring in SRE for the cloud team? Well, we quickly discovered that traditional operations is not necessarily the best model, especially when you're supporting a critical banking function or functions, as well as other critical bank workloads. So this is like a traditional model here. A user notices an issue. They call in to help desk, log a ticket. That ticket is raised to the appropriate support team. Hopefully it's the correct team. The problem is investigated, identified, resolved, and then finally the user is notified. Not the optimal way to handle incidents. Obviously, this is not something that we could support a very robust and cloud-native type of application. As I mentioned before, the Pivotal platform at RBC supports critical banking functions and other critical workloads. We realized it would not be possible to support such high-valued and profit-making businesses with using the traditional approach to operations. We needed to be able to offer a platform that had high availability, supports low latency transactions, and has proactive measures for monitoring and alerting. So what did we do? First things first, we with the help of our Pivotal engineers and educating ourselves through various means, we started and decided to adopt an SRE mindset. We met with one of the more advanced app development teams who are leading the transformation to cloud-native and agile practices. This team happens to own that portion of the critical banking functions within the personal and commercial banking organization. We came to an agreement on service level objectives that were both acceptable to them and achievable by us. And again, this is an ongoing journey that we understand that will never end. We just want to continue to iterate, tweak, and improve on. So it's very important for us to be able to adhere to enterprise policies. Obviously, through audits and compliance, that being a financial institution, we do have to meet those needs. So we do have access to production, but we control this and log it through a privileged asset management solution. Because we have to be agile and our businesses are agile in nature, we have to often make changes and common tasks through standard change templates, whereby this cuts down a lot of time as opposed to creating ad hoc change requests. Through that, we've eliminated an approval process, which again speeds up provisioning to production. And this too, SRE allows us to work in an agile environment, so always meeting our business users' ever-needing demands. And we are actually implementing changes to the platform during business hours. And a lot of people may say that this is a no-no, but we are able to do this based on the resiliency of this platform. And also, you want to be making changes during the day so you have all your subject matter experts on site. This is a quick roadmap of our journey. As you can see, it's not a straight path. Obviously, we started with a small subset, and we used a pipeline to deploy the platform products. And through various iterations, we were able to create multiple pipelines. But that wasn't good enough. We wanted to improve our efficiencies there and combine the pipelines. So in doing that, we wanted to now kind of set a standard where we could use these pipelines across disparate platforms, as well as we will continue to learn from any mistakes or errors that we run into as we iterate through. You can see a common theme here. I do mention pipelines. That is achieved through a lot of automation. And I'll leave it to John to explain how we leverage automation and eliminating toil.
Okay, thanks, Ron. So toil is defined as repeatable manual tasks that can be automated. So our philosophy at the bank is to try to reduce toil as much as possible through automation. Concourse, in case you're not familiar with Concourse, it's a continuous thing doer. It is our CI/CD tool that we leverage to automate the jobs and tasks organized through pipelines. We really like Concourse because of two main reasons. It allows us to express pipelines in code that can be stored in Git, and also so that the tasks are run in containers, which ensures repeatability. So soon after we installed the Pivotal platform, we realized that it would be a lot of repeated work involved in onboarding application teams. And as we mentioned earlier, we have over 200 application teams onboarded to Pivotal platform. And so one of the first pipelines we created was something that was based on the CF management utility, so that we could add, update, delete org spaces and users. RBC uses an LDAP for authentication, and the orgs and space users are managed via LDAP groups specified in a CF management config. And we store that config in Git, and then when pull requests are merged to master, the pipeline creates the orgs and spaces and users based on the LDAP group memberships.
Gotcha.
So this is an overview of or screenshot of the CF management pipeline that we're using. And you can see some of the jobs are triggered by new versions of the configuration showing up in the master branch, while other jobs are triggered on a schedule. And the ones that are triggered on a schedule are there to adjust the users and roles based on LDAP group changes that may occur asynchronously to the platform. However, there was still some toil involved, right? Those pull requests had to be reviewed to ensure that the correct config syntax was being used and that the LDAP groups existed. So that we wanted to eliminate even more toil. So our team created a new pipeline triggered by the pull requests that reviews and merges those pull requests if they're submitted by a known service account. There is a much higher level pipeline that's part of our next generation developer portal that's owned by our DevOps team. And when it onboards app teams to RBC cloud platforms, specifically the Pivotal platform, a pull request is created that updates the CF management config, and then this pipeline will review that pull request and merge it automatically, therefore eliminating any manual intervention by our team. I'm going to turn it back to Ron to talk about the repaving pipeline.
Thanks, John. So continuing along with the theme of automation, we use a job or a pipeline that's called a Bosch repave. This is a code repository that's offered through Pivotal Services. Simply put, it's a concourse pipeline that recreates Bosch managed VMs. It allows us to meet one of the R's of the 3 R's of security. So if you listen to the security audit and compliance talk yesterday, you'll hear them speak of repave as one of the important components of security. The other 2 are repair and rotate. As well, and probably more importantly, this meets internal control objectives of installing patches on long-running OS instances and adheres to current organizational patching SLAs. It ensures that any compromised VMs will be reset to a known good state or a gold state. And the more often we do this, the less opportunity for compromised VMs. As I mentioned, this is a concourse pipeline. This is scheduled on a 30-day period right now, so a monthly period. It is issuing a Bosch recreate command against the specified deployments. Currently, singleton instances are excluded to prevent downtime of individual services. You have the option of omitting specific deployments or only specifying certain deployments. However, with our MVP deployment of this, we select all the deployments with non-singleton jobs. Our future plans for this are to improve this to show or report on key risk indicators, such as VM uptime. This is important for auditing purposes. Also, we want to recreate multiple VMs in parallel to speed up the pipeline, as well as run this pipeline multiple times per month. Again, going back to that talk on security auditing and compliance, they're recommending once a week, and there are other organizations that do this. So we're looking to get there. This is an example screenshot of our concourse pipeline. You can see this is a trigger off of a monthly cron schedule that actually kicks off the repave. Slightly before the repave starts to go into action, it puts a lock on the deployments so that nothing else can kick off and interrupt it. If the repave is successful, we get a green. If not, we'll get an alert sent to our alerts solution. If the lock is not required, it will also fail. Okay, and so this is an actual video demo of the pipeline in progress. So as it scrolls through here, I'll just talk through it. This is of our sandbox environment, so we have very few deployments within the foundation or the platform. You can see here that we are able to select multiple deployments. There's a CF deployment there. And below that, it'll name all the VMs that are part of the platform. So Clock Global in this case, it's non-singleton. As you can see, there are 3, and it does them serially, pardon me. And there's also our Diego cells. As I mentioned, as part of doing this serially, we have noticed that it does take a long time. This being our sandbox environment, it took 5 hours just to do a small deployment. You can see some other deployments here, and that's the end of the video demo. And I'm going to hand it back over to John for some more automation.
Okay. Recently, we added a new platform automation pipeline. Prior to that, we were using PCF Pipeline's Maestro to automate our product upgrades. However, product tile configurations were made manually in the Ops Manager GUI, and it was a chore to keep the configurations in sync across our non-prod and prod platforms. It also meant that our team had to have OpsMan admin access whenever they wanted to make changes. So with this new pipeline, which is based on the Pivotal Automation product, we have automated product configuration and upgrades while following the infrastructure as code principle, since all the configurations and versions are stored in our Git repository. We overcame several challenges while developing this pipeline, and I'll talk about some of them in a minute. And now that we have this pipeline, we actually consider kind of a bad practice to go in and make manual changes in the OpsMan GUI. So I'd just like to give you an overview of the pipeline and its design. We wrote a Python script that's used to generate and fly the platform automation pipeline. It takes Jinja 2 templates and product configuration files and product version files as input. And it produces a single pipeline YAML file and flies it into Concourse. When the pipeline runs, there's a task that uploads products to OpsMan, and that's reading those products from our on-premise S3 storage. After the product changes are staged, the pipeline validates that the stage configuration matches the configuration in the OpsMan, in the Git. Finally, the apply changes step is kicked off and within OpsMan via the pipeline.
Cool, great. So I gave an overview of what SRE is defining: service level indicators, service level objectives, error budget, KPIs. So I'm going to explain to you what we did, what our actual SLIs are and SLOs. So we have 4 main ones that we measure. The first one being the CF API availability, and this measures the availability of the CF API in percentage. So think of this as your gateway to the platform. With that not being up, essentially your platform is not useful. The next one that we have is a CF push time. And if you listen to James Waters' keynote speech yesterday, you would hear him say that CF push is sacred. It is, from a developer's perspective, sacred. We measure that in the duration of seconds that it takes to push compile a simple Spring app. It binds to a few services. It does a CF push and a start. The next 2 are very closely related. They are what we call a representative application, or think Canary app. We measure both the availability and the latency of these two. So the availability is measured in percentage, and that is again compiling an app, binding to a couple services, pushing to CF and starting it. And the latency is measuring the latency to that act by way of milliseconds. Okay, so here's a sample manifest of that representative application. I won't go through all the details here. It's pretty simple, but you can see here that there are the data services that we bind to. There's some health check values provided, as well as, and probably more importantly, are the routes. And so we have two routes that we recommend and that we actually measure. The top one being a global route, and the bottom one being a local route. Local route is obviously for the foundation or platform that the app has been deployed to. The global route is sitting on top of a load balanced rule that is DNS enabled, that's able to route the traffic to either prod A or prod B. Okay, and so here's some actual dashboarding that we're using for our SLIs. Again, this is the CF API availability. We have the SLO posted at the top there, so we have a constant reminder, and obviously anybody can consume that. You can see here what we have is 3 of our 4 platforms, a non-prod, a prod A, and a prod B. And we measure that or chart that on 1 hour, 1 week, 1 month, and 3 months periods. We're doing really well with our 1 month, and we obviously need some improvement in the 1 week. But as you improve along your and you stay steady along your 1 hour, that continues to improve further out. Next is the CF push time. So we're measuring this in, well, it's measured here in seconds, easier to show, but our SLO is 2 minutes or less, again for the 3 platforms. So we actually have the current value as well as a time series graph to show how we're trending. For that sample app that I said. Yeah. Can I hold all questions till the end? Because we have a lot of content to go through. Yeah, thank you. All right. So next one is with the application availability. So this is that representative app or that sample app, and that's what we're measuring against here. Non-prod, prod A, and prod B. So we've got this sample app pushed to every foundation that we measure. Again, we're measuring them on the 4 time intervals, the 1 hour, the 1 week, 1 month, and 3 months across the 3 platforms. And lastly is the latency. And this one is good because we showed that and we've come to agreement of 500 milliseconds, which probably is not as tight as we want it to be. And you can see that based on the metrics that we've charted here, we're well within that means. So this is something where, as part of our SRE, you got to keep going back to and improving on and look to optimize. Last thing is the error budget. And again, just to summarize, the error budget is a set amount of downtime or degraded level of service allowed in a 30-day rolling period. You can we kind of sum it up as how much time do I have to either break or fix stuff. Not break in the sense of intentionally, but there is always the opportunity when you're deploying new features or upgrades that things go awry. So that's what I'm referring to as break. And obviously we're not releasing any new features if we've exceeded our error budget. And this is how we're charting it here. So again, we're using the error budget against our app availability. So that's our representative app and our representative app latency. And again, our latency is we have been meeting those SLIs or SLOs quite well. Our app availability, maybe not as much. I'll speak to that in a second. Kind of ties in with our next topic, which is measuring and alerting on the right things. So, users don't necessarily care about CPU and disk usage. I mean, maybe some ask, but are they really relevant to their experience? Probably not. They really just care about how long or it takes to push their app to the platform. How long does it take for me to get a request back from my app? We want to measure what the users care about. Okay? So we're not actually charting disk usage and CPU usage, or actually defining our SLIs on those. However, we do actually keep monitoring on those because we want those for debugging purposes or proactive measurements, and we will continue to keep alerting on those, but only to ourselves for debugging purposes. So this is where I was going to get back to. Monitoring agents you have to rely on, and sometimes they're not always reliable. But is it their fault? Probably not. They're built to work across a broad scope of organizations. So who monitors the monitor? One of the things or challenges that we've had is that we use a proxy to tunnel externally, and we've had challenges in getting some of our metrics out of that proxy. So that is not necessarily the monitor's fault or the monitoring agent's fault, but a lot of the infrastructure components that we rely on. The next point is, as the platform scales, you have to scale your monitoring solution. So we quickly came to realize that as our non-production environment scaled, that we were sending tens of thousands of metrics out to our monitoring solution. Some of the metrics that we didn't really consume, weren't charting, weren't alerting on, not even monitoring on. So through help with our vendor, we've excluded those metrics that are not required. And lastly is alert fatigue. Obviously, we've learned a lot from that. You don't want to be sending everything to an alert. That gets a lot of people into the idea of just ignoring alerts, and we want to alert and be reactive to those if they do exist. Alert fatigue causes your team to be tired, frustrated, not coming in with good ideas, and we want the opposite. We want fresh ideas, we want to be able to innovate, so we want to avoid alert fatigue as much as possible. So one of the ways we can do that is through a cool tool called chaos testing, and John's going to speak about that.
Sure. Google's SRE book has a whole chapter on testing for reliability, and they go through various testing methods. And one of the testing methods that we started to use several months ago was chaos testing. Chaos testing is defined as deliberately introducing failure into your systems and processes to try to understand how things are going to react and to try to improve things so that when they do occur for real, that you're better able to address them. Our goals for chaos engineering are twofold. One, to improve our mean time to resolution by making the platform and the team more resilient. We're also looking to understand better how or when to engage other teams like our infrastructure team when an incident occurs. Prior to a few months ago, we had limited ways to understand and prove the platform was resilient. We were also unaware of the actual impact in various failure scenarios. We also found that the team had low confidence with respect to investigating issues in high stress situations. So what we did was we installed a chaos testing framework called Turbulence, which is a Bosch release that allows us to define and simulate failure conditions. We also created some of our own tools. For example, we created a big logger utility to generate a lot of logs into the system in order to see how the logagator system was functioning. At this point, we've tested over 20 scenarios, ranging from minor failures to full availability zone failures. We have learned a lot about how the system reacts to each of these failure conditions. Just to give you one example, we found that Bosch could go into a meltdown state. If more than 20% of your instances are down, then the deployments in a deployment, then Bosch will consider it a catastrophic failure, and it's better just to leave the system alone and not try to resurrect the VMs. So we actually are going to add some monitoring because otherwise you don't really know when BOSH goes into that state. So I'd like to show you a quick demo of a chaos test. In this scenario, let's assume that all the Go routers in availability zone 1 have crashed. Now we don't expect any end user impact in this case because we leave enough headroom in our Go routers to allow for this type of failure. On the right-hand side of the screen here, we're showing the turbulence definition for that failure scenario. The tasks section describes the type of failure we're going to inject, and the selector section describes which VMs we want to be targeted. After the failure is injected, we expect in this case the BOSH resurrector will recreate the Go routers, because especially in this case where I was using it on a small foundation, the number of Go routers was fairly small. So BOSH did not go into its meltdown state. Okay, so let's go to the next slide, and we're going to, so I have a little recording here. So the recording is of 2 terminal windows. On the right-hand side we're going to run a script to inject an incident into and send the definition to turbulence and have it inject the failure. On the left-hand side, we have a watch command watching the Go routers on the deployment, and it's refreshing every 10 seconds. This is a time-lapse kind of video, so it's going to go through about 10 minutes of video, but it's going to only take a few seconds. So you can see on the left-hand side that the agents became unresponsive in the VMs, and then BOSH starts kicking in and starts replacing those VMs, and eventually at the end all the VMs are running again. Okay.
Next. There you go.
Okay, so I wanted just to summarize sort of where we are today with chaos, we think we're well more prepared to deal with chaotic scenarios. We're also able to craft game day scenarios, and I'll talk about game days in a minute. The team also understands the Pivotal platform to a much higher degree, and they can also troubleshoot a lot better than in the past. So now I'd like to talk to you about incident management. As we mentioned earlier, we are a small, diverse team with various backgrounds and experience levels. We are managing a platform where the changes and the new features are added regularly. And we have an incident process, but maybe it's not well known, especially for new members of the team. So the solution we came up with was game days. Game days are about role playing during simulated incidents. Okay, so game days are usually planned events, although we may eventually do some unplanned ones, where a failure is injected into the platform to simulate a real incident. The team follows the established or incident process to troubleshoot the issue and bring the system back to health and communicate outwards to all the stakeholders. Game days help us ensure that the platform is resilient with well understood recovery processes. Game days also build confidence with the hands-on troubleshooting experience and allows the team to actually practice the various incident management roles. Let's go on. So here's a quick overview of our game day process. So basically the day before game day, we'll have a meeting and we'll discuss what kind of scenario we want to simulate. And that may be based on things that we've seen in the past or potential scenarios we've heard about. And then on game day, there is the incident commander gets assigned, gets the chaos event simulation triggered. And once the chaos event has been triggered, the incident responder who happens to usually be the person on call that week, will follow the incident response process to resolve the simulated incident. And the incident commander also will then update the game day log with the details of the simulation. And finally, an important step is to have a post-mortem and write up the activities from the day. So we've actually run several game days over the last couple of months, and in the interest of time, I will go over one of those examples. We have included 3 examples in the slide deck, so you can refer to those afterwards. So the example that I'm going to go through here is we call it example B in this case. Is what we did was we unmounted the ephemeral and persistent disks in the CF MySQL VMs, and we did this to try to simulate storage failures that we've seen in the past. And when this happened, the CF push would fail, and also a lot of other CF APIs would fail. The way it was detected was through our smoke test. We have a smoke test that's running every half hour that's ensuring that the platform is functioning the way we expect. And then there's also a lot of the SLIs that Ron was talking about. They were also failing. And then our level 0 support team, was aware that there was going to be a game day, but they were supposed to treat it like a real incident. They paged out the engineering team. The incident responder, who was was assigned ahead of time, responded to the incident and started investigating. The incident commander then started, sort of was quarterbacking the effort, and when the amount of activities got too much, he delegated to another person to do the actual communications, and there was communication sent out regularly as the incident responder was working on the resolution. So the question was this done in production? No, we haven't got to that stage yet, but this was done in our sandbox environment. So in this case, we actually, it was a little bit unexpected that we learned something here too, is that in order to recover the system, we actually had to go into the IaaS layer and shut down all the VMs, the MySQL VMs, because trying to recreate them from Bosch directly did not work. As soon as we shut them down, though, Bosch was able to recreate the MySQL instances. So then we had 3 VMs up and running, but it's a cluster, so we had to actually bootstrap the cluster to make MySQL come back online. Once we did that, then the system came back to health. So this was a fairly long game day. It took 5.5 hours, but we learned a lot by doing this. So highly recommended to adopt the game day process. It's been very useful for our team. Okay, go to. So some of the lessons learned here. So the team really liked to do the game days. They really got into it. They really liked the troubleshooting aspects. So but the incident response process, wasn't like, there was a little bit less focus on it. So what we're going to do in the future is we're going to have a game day where we don't inject any chaos, that we just tell the incident responder that there's an incident and that we want to follow the incident process, and just focus on that process. Tracking mean time to acknowledgement and mean time to resolution are metrics that are very important to prove that game days are helping the team, and so we want to keep accurate logs of the timing of all the steps that we've been following. Also, it's very important to hold postmortems because that's an essential way to to figure out what improvements are needed and to make sure that mistakes are not repeated. So I'm now going to turn it back over to Ron, and Ron's going to talk about a few things that we're thinking about doing next with respect to SRE.
Thank you, John. So what's next? Obviously, no journey is complete without its challenges. So yes, we did have challenges. And so we've raised them. And some of our challenges that we've yet to resolve are reducing the number of alerts. Again, that speaks volumes to the amount of alerts that you're getting, and trying to dissolve or remove alert fatigue. We want to also add more service level indicators to ensure our users' experience is optimal. We want to actually use error budgets to determine when new upgrades and new features are added. As well as we want to automate chaos testing in non-prod and possibly someday in production. As well as we want to include other teams in our game days. Obviously, we depend on a vast amount of teams in our entire infrastructure, as well as our incident management, change management. So we definitely want to include them in part of the process. So just to wrap up, I just want to have a couple comments or make a couple comments. As long as you stick to principles of site reliability engineering, and remember you're solving operations problems like a software issue, you too can successfully adopt an SRE mindset. We hope you enjoyed following along in our journey. We hope that you've learned something. Hopefully, if you have not started SRE, we highly recommend it. And if you have, we encourage you to share your challenges and your successes with us as well. Lastly, we would like to give credit to our team and our pivots who made this possible. We are a small team, as we mentioned, as well as a couple of pivots that we depend on, and a lot of this credit goes to you guys. And now we'll open up the floor for Q&A. And if time permits, we can take it outside. Thank you.
I know you. Go ahead. So what was your timeline for when you first brought in Pivotal to when you started the SRE process later now?
So that's a good question. You want me to take it?
Ask the question first.
Okay. So what was the timeline from when we brought in the Pivotal platform to when we adopted SRE? So we actually have had the platform deployed since September 2017. We actually went through our initial dojo then and deployed the 4 platforms then. It was really not until I guess summer of last year, or so to speak, we started engaging with our pivot, Andrew, who kind of opened our eyes to platform reliability engineering and how it's done at Pivotal. And then we took that and kind of ran with it, and with, like I said, with the Google SRE reference, we kind of adapted from that point on.
So you actually had a pivot help you go through the SRE transformation?
I wouldn't call it, he had a follow-up question, is we had a pivot come in and do a transformation. I wouldn't call it a transformation per se, but it was more of an educational session, just showing us what can be done and what has been done. And then we kind of put our own spin on it, obviously following the principles.
Was it Andrew Wood?
You know Andrew Wood. It was Andrew Wood. Yeah, we had him listed here.
Yeah, I think the gentleman in the blue shirt first.
Andrew Wood's a good guy.
Andrew is a good guy.
He still is. Even though he's Canadian.
We'll talk
about that another time. Anyway.
A boot.
So you said no patching if error budget is exceeded. What about in regards to security patching for CVEs?
John, would you like to handle that?
Yeah, so for that kind of patching we do. I mean, we are going to do that, and that is sorry. The question was for security patch. We said that we didn't do any patching if our error budget was exceeded. That was really a comment towards more like adding new features and or upgrades. But for security patching, we would definitely go ahead and do that. And that's a pretty safe process with the Pivotal platform. So, okay, next question I think was in the back.
Coming back there, yeah.
Yeah.
Question was, how much of game day principles did we inject into applications such as latency?
Yeah, so so that's one. So we haven't really had our app teams involved in our game days so far, and that is something that we want to do, but we haven't done that yet. So we've had enough. There's enough. The platform itself is big enough that we had enough scenarios to go through. So now that we're a little bit more mature with our game days, we will start inviting app teams and also our infrastructure teams to be part of our game days.
And I think, just to follow that on, John, I think just with the SRE mindset itself, it's kind of now propagating throughout the organization as well as into the app teams. And so I have heard of app teams kind of injecting their own chaos through various means.
You guys focus solely on uptime for your error budgets, or do you guys go after enumerated list of all the things that the customer cares about and work backwards with your metrics?
The question was, do we solely rely on uptime, or do we go through a long list of what our customers care about? It's a combination of both. Our SLIs and SLOs were actually determined with the actual interview process with our critical banking services team. That's the team that's very forward-thinking and cloud-native transforming. So we essentially went through an interview of questions, what's important to you? And they kind of came up with a list of, app latency, how many times can I push? How long does it take for my request to come back? What's the availability of your platform? And we kind of just morphed that into our SLIs that we have today. Again, we are always looking to improve that, and through the help of our app teams, we will continue to get a longer list. Yes?
What would you say the learning curve for using tools like Concourse and Bosch was, and do you think that was made it harder for you guys your team to do this?
Yeah, so the question was, what is the learning curve like for Concourse and Bosch? For Concourse, I think it's pretty straightforward. I think our new team members would go through like tutorials that Stark and Wayne or whatever or other training to get up to speed. That was pretty quick. Bosch is it's a much steeper learning curve. It probably takes 2 or 3 months for new team members to really get comfortable with it. But it's also a powerful tool. So we really believe in using Bosch and not being afraid to use it, because it's really powerful, and it does a lot of things that you wouldn't want to be trying to do some other way. So
Yeah.
so we highly recommend Bosch.
Yeah, we've actually looked to use that in other components like a Kafka, and that's now available. So
Let's go over here.
What was your single North Star metric that you apply your SRE principles, SREious?
So the question was, what was our single North Star metric that we apply our SRE principles to? I think that's pretty easy for me. That's the actual API. Again, like I implied, that's essentially the gateway to the foundation of the platform. Without getting access to the API, obviously everything is just a wash. So the CF API. So if I issue a CF login and I can't log into that API URL, I can't push, can't do anything, can't stop. Right. Question way in the back.
Is there any pivotal specific resources to do SRE? Like a blog or some?
Pivotal the question was, is there any pivotal resources that are available to implement SRE?
Yeah, within the pivotal platform.
Within the Pivotal platform specifically. There are a couple blogs that we've referenced. There are some good ones that I know that they've posted on Pivotal.io. There is a webinar as well, like a podcast even. SRE, keep in mind, SRE is just a set of principles, and if you use those guiding principles, it can be applied anywhere. I've listened to a podcast of one of the folks at Google, and he said that he went to a law firm and they're implementing SRE principles. So you can see how it's wide reaching.
I just wanted to say, if y'all wanted to talk to me about SRE after I'm in Pivotal Platform Services, I'm happy to talk about it. I'll be outside.
That's Clayton from Pivotal. Great help. Next question.
So, for your game day exercise, do you expect to have the same mean time to acknowledge and mean time to resolution in production? You know, given that this your lower level, it's a coordinated exercise, right? So you already know what's coming in compared to if it happens in production unplanned.
So the question is, for mean time to acknowledgement and mean time to resolution, do you expect it to be, I think, faster in production than?
Or yeah, I mean, how relatable it is compared to a lower level versus production.
How relatable.
Yeah, so I think it's more to do with like if we've seen the incident, if we've seen either the same incident or a similar incident before, then definitely the practice has helped to make it faster. Some of the duration example that I was showing there was really because we were learning as we go, so we don't, it's not all about just like getting the platform back to health as soon as possible, but also learning as we go and communicating with the rest of the team. So, but I would expect it to be faster for sure, like if we've seen these kind of issues before, which is, that's why we're trying to practice.
You tend to get more leverage in production, obviously. Yeah. Any more questions? If not, we got one more.
I saw your slide for the chaos testing. It talks about dirty AZ failure.
Yep.
What is a dirty AZ?
Okay, so the question is, on the game day slides, we talked about a dirty AZ failure or availability zone failure. So we've seen cases in the past where a storage issue occurred, and I would say a significant portion of the VMs in an availability zone were affected, but not all of them. So the load balancer and stuff would still be sending, there'd still be requests, and there'd still be, with some VMs up and some VMs down, it's kind of unclear. It's a little bit less clear about what's going on, and also requests are somewhat being handled in that availability zone. So you get a lot of failures that are hard to that just sort of make it harder to troubleshoot. And so we found that it was actually easier to recover if the whole AZ had just gone offline and come back online. That's what a dirty AZ failure is about. Okay, if there's no more questions, or if we will be outside, we would love to talk to anyone that wants to talk offline, and we can talk more about SRE. One last thing I would just like to mention that we've branded our Pivotal platform at RBC as Cloud Fortress. This is something that happened over the summer with our Pivotal friends encouraging us. And so I'd also like to shout out, we have a lot of our team here, and they're all wearing the shirts too. So just trying to explain what the Cloud Fortress thing is all about. So anyway, thank you very much again.
Thank you.